All right, the last second question that we'll do is just to determine whether lines are parallel, perpendicular, or neither. Okay, so it's basically a multiple choice question, right? We have three answers: A, parallel; B, perpendicular; or C, neither. I don't want you to put A, B, C, but just I want you to put those words, but one of those words. But I, just want to point out that there's only three possible choices to this, right? Um, so anyway, so we want to find the slopes of L1 and L2, and then if they're the same, that means they're parallel, right? So let's just work this out. So if the lines are parallel, then the slope of one is going to equal the slope of the other, right? If the lines are perpendicular, then that means that the slope of one is going to be the opposite reciprocal of the other, right? So meaning one will be one over the other with the negative, right, or the opposite sign. Okay, and then neither means that none of those two things are occurring, right? They might be reciprocals, but not opposite reciprocals, or they might be opposites, but not reciprocals, or opposites, but not exactly the same. Okay, so be careful because those are the ones they'll trick you with, are the ones that are just regular reciprocals, or if they're just opposites, then those are not parallel, nor are they perpendicular. All right, so what we'll have to do first is find the slope. Okay, so find slope, and then we're just going to compare the slopes, right? All right, so L1, so we have 3, 5, and 4, 7. So remember, one way you can always do this is graph it, kind of like we did in the last one. You can graph it and then visually look at the slope. But since we're given the points, we can just use the formula as well. So remember, our formula is that slope equals y2 minus y1 all over x2 minus x1. Okay, so for L1, we'll use blue. So for L1, or we'll call the slope for L1 M1. We're gonna do y2. We'll call it 7 minus y1, which is 5. So y2 minus y1 all over x2 minus x1. x2 minus x1. So 7 minus 5 is 2. 4 minus 3 is 1. So M1 is 2. All right, so now let's find M2. Let's find the slope of the second line. So y2, 9 minus 7. Okay, y2 minus y1 all over x2 minus x1, right? So 12 minus 11. So 9 minus 7 is 2. 12 minus 11 is 1. 2 over 1 is 2. All right, so now let's compare. So 2 and 2. Does M1 equal M2? The answer is yeah, they do. And therefore, M1 is parallel, right? That's the symbol for parallel, M2. Okay, so you can leave it like that, or you can just say parallel. That's fine with me. So that's how we do it. Let's try another one. So number 50, L1, L2, same thing, right? So I'm going to find the slope of L1. So it's going to be y2, which is 0 in this case, minus y1, which is negative 2. So it's going to be minus a negative, right? Because there's a built-in negative in our formula, y2 minus y1. So sometimes you have to minus a negative. Then on the bottom, it's x2 minus x1, right? X2 is 2 and x1 is negative 2. And so on top it's really 0 plus 2, bottom it's 2 plus 2, so it ends up being 2 over 4, which reduces to 1/2. Okay, so that's our M1. M2, okay, y2, 3 minus y1, which is 5, x2 minus x1, right? So it'll be -1 minus -2. So negative negative turns into a positive. And on top, 3 minus 5 is -2. On bottom, -1 plus 2 is +1. So we end up with a slope of -2, right? So let's do our check. Does M1 equal M2? No, that's not true, right? So therefore they're not perpendicular, or excuse me, they're not parallel, I should say. Okay, so now we check, is M1 the opposite reciprocal of M2, okay? Are they opposite reciprocals? Okay, and if we look at them, right, especially if we look at this and this, we can see they're opposite reciprocals, right? They're opposites because they're one's positive, the other's negative, so that's a check, right? And they're reciprocals because one is 1/2 and the other one's 2/1, right? So they are opposites and they're reciprocals at the same time, therefore they're perpendicular. So the way you would say that is you'd say M1 is perpendicular with M2. So this is the symbol for perpendicular. It's kind of an upside down capital T. Okay. All right. Do a better job with this. Okay. It doesn't have to be so that big either, but all right. Okay. So let me know if you have any questions. Write them down. We have one more example. All right. So determine whether L1 and L2 are parallel or perpendicular or neither. So process of elimination is our last example. You can maybe guess what this one's going to be. Let's work it out. So so our first slope, y2 minus y1, so -1 minus -3, all over x2 minus x1, right? x2 minus x1. All right, so once again we have a negative negative. -1 plus 3 is 2. 3 minus 0 is 3. All right, so that's our M1. Let's check out M2. So this is the slope for our second line. Here we have fractions. -5/8 is y2 minus 1/2 is y1 all over x2 -1/4 minus x1, which is 1/2. All right, so now we need a common denominator. So on top, I'm just going to multiply by 4 on top and bottom, right? So I'm going to get -5/8 minus 4/8. And then on bottom, I'm going to multiply by 2 on top and bottom, right, to get a common denominator of 4. So that'll give me -1/4 minus 2/4. So on top, we'll get -9/8. On bottom, we'll get -3/4. Okay, so here we have a fraction over a fraction. So remember, the way that we divide fractions is we take the numerator fraction, -9/8. Well, let me write it like this first. So this means the same thing as this, right? So we're just dividing numerator divided by denominator, right? And the way we divide fractions is we flip that guy and multiply, right? Or the way I think you're trained to say it is -9/8. So you keep, change, flip, right? I think is how you say it. So keep, change, flip. Flip that guy, multiply is how I like to remember it. Either way is fine. But when we multiply straight across there, -9 times -4 is +36. And 8 times 3 is 24. Okay, and then we can reduce that. So 36 and 24 have a common factor of 12. So 36 divided by 12 is 3. 24 divided by 12 is 2. So we end up with 3/2. All right, so that's what we get right here. All right, so cool. So that's the work for that. You can definitely rewind and pause if you need to. All right, so let's compare now. Does M1 equal M2? No, right? 2/3 does not equal 3/2. So they're not equal, therefore they're not parallel, right? You don't have to draw all this stuff out. This is just kind of mental math, and or if you want to draw it out, that's fine, or you can operate some of this stuff on your calculator. All right, so the next one we'll check for is are they perpendicular? So is M1 an opposite reciprocal of M2, right? Are they opposite reciprocals? Okay, so let's check. Are they opposites? Is positive 3/2 the opposite of 2/3? The answer is no. They're not opposites. Okay, so they're both positive, right? And so right away you don't even have to check for reciprocals, right? It doesn't matter. They're not going to be perpendicular. Okay, so M1 is not perpendicular with M2, and so anyway, so our answer is going to be, you guessed it, neither. Okay, or if you show this and this, that's fine too. Okay, all right. So watch out for those that they'll trick you right here. It's a little tricky because they are reciprocals, but they're not opposite reciprocals, right? So they have to be opposites and reciprocals for them to be perpendicular, and they have to be exactly the same sign and everything if they're going to be parallel. The slopes have to be the same. All right, hope you enjoyed that, and yeah, bring any questions if you have them to class, and get ready for those finals.